Hey, good evening, everyone. Can we hear me? Okay, we're just five. From what I'm saying, we're just five on the call at the moment. So let's give 3 more minutes for others to join in, so that we don't have to be going back and forth. So we'll start by 7:05. On dot 7:05. So let's allow more people to join in. If you can send reminder to others, please send reminder to them. Notify them that we've started the class. So let's give grace of 3 more minutes for others to join in. Yeah, while we're waiting, that was our day. Good evening, Nilolawa. Good evening, Deborah. Okay, we have 21 people now. 2 more minutes. My day was fine. It's been workful. It's been workful. Yeah, but it was fine. Okay, we have just 19 people on the call. I don't want us to start and then some people say that they joined in late though. We will not go back today. Oh, thank you very much, Esther, for asking. I'm better. Still have a bit of cold, but I'm way better. Thank you. Victoria, no, this is not cybersecurity class. This is cloud computing. This is cloud computing class. Happy my day was fine. Okay, we have just 1 more minute left and we'll get started. Just a minute left. We have 23 people on the call now. Take count. Okay, so it's 7:05 on the dot. Like I promised, we're going to start 7:05 on dot. So let's get started. Those that are yet to join us will join us on the way, wherever it is that they meet us. Okay, so good evening once again, everybody. Please confirm you can see my screen. I think I already confirmed that you can hear me clearly from our responses. So confirm that you can see my screen. Okay. All right. Okay. So thank you very much. So today is the last day of this week teaching on networking in AWS. And it's been quite a lot to take in since Monday, but I trust that we've all been coping and we're not confused. Now we're not confused at any point. I was not able to join yesterday's class, but I listened to it today and I said I was amazing. Mr. Moses did a very good job as usual. So today we're going to be looking at securing your VPC with security groups and NACLs. I remember I would have probably mentioned security group in passing, maybe as at then we're talking about EC2 instances. So today we're going to really be diving deep into security groups and NACLs. Besides, NACL is an acronym as always, right? So you get to know the full meaning of NACL as well. So without wasting more time, let's get right into it. So, seeing as today is the last day for this teaching for networking in AWS, I just did a one slide recap of everything we've been talking about, right? We spoke about VPC and we talked about how VPC is like having your own private space in the AWS cloud. I remember us using an example of purchasing a land for a school campus, right? And we said VPC is like that's land that you purchase, right, for the school campus. We said in the VPC you have subnets. Subnet are like your buildings that you have on that land, and that building is where your resources would be sitting. So your resources can be like the rooms inside. So your EC2 instance, your database instance, and whatever it is that you want to put will be inside the building, right? And then we mentioned that your VPC is what region bound, which means every VPC you created is created within a region, while your subnets are created within an availability zone in that region. Right. So we also spoke about route table. I would say route table is basically what provides direction to your network traffic. Tells you that okay, if you are going to a mail hostel from main gate, this is where you pass, and there's a road that actually leads to the mail hostel. That road is not blocked, or that road is blocked, whichever one that is the route that you put there. Right. We talked about gateways. They're like your gates and your doors. And I remember we talked about internet gateway. Mr. Moses spoke about NAT gateway, right? Yesterday, right? Yeah, yesterday. And he also talked to us about VPN peering, right? He also talked to us about elastic IP yesterday. And we said, unlike your public IP, that's whenever you shut down an instance or you stop an instance, that IP is detached. If you restart that instance, it will give you a new IP address. So to avoid those kind of things, right, it's usually advisable that you have an elastic IP address. So no matter what happens, you always have that IP address, and you can always detach it and reassign it to another instance as per your choice. So the elastic IP would stand the test of time, basically. All right, so that's a recap of what we've done this week so far. So let's get to today's own. Now, I'm starting today's own with this particular one, and please don't be scared. This is not something for you to cram, right? There are some of them that will become. That's why I've put it as common network protocols. There are a lot more than this, right? But I've also included a link to additional resources where you can go and read up more on this. So why am I starting with network protocols is because it's something we're going to be meeting by the time we're discussing security groups and ACL. So we need to deal with it first, basically. So a network protocol is basically like a standardized set of rules, right? That allows computers to communicate together. So for every form of communication, every form of data, there's a standardized set of rules, right? So there's a body that regulates these things. She gets so these are not things that was fabricated by me. These are general rules that you'll find anywhere applies to everybody, basically every network rule. So these are some of the common ones you will come across. The HTTP protocol, and the port number is usually 80, and the HTTP protocol is what you use for web traffic, like when you want to do something on the website, on a web, for example, your web browser. That protocol is running on HTTP. So anything web runs on HTTP. So if you find that you want to write your website address, you see HTTP, some will be HTTPS. Now, HTTPS is a secured version of HTTP. Has it ever occurred to you or happened to you before that you go on a site and then Google Chrome will tell you that this site is not secured, right? It's not like the site will not open up, but to give you a kind of a caution that this site is not secured, right? So Has that happened to anybody before? Has it happened to any? Okay, all right. So, patience. All right. Thank you. Okay. So, when you have a site telling you that caution, this site is not secure, right? That is usually an HTTP site, right? So it means that there's no security certificate or credentials that has been uploaded to that site. So those kind of sites are usually easily hacked, right? Your those kind of sites, they are prone to attacks. So your data is not very safe on those kind of site, and that's why whatever web browser you're using will give you a caution note, so that if you want to proceed, it is at your choice, basically. So HTTPS is um the secured version of HTTP, right? So you find out that some web address, they have HTTPS, then the dot, then slash, whatever the name of the website is, right? So anywhere you see HTTPS, it means it is using a secured version of the HTTP. And unlike the HTTP, it runs on port number 443, right? So again, please don't bother your head about how this number came about, right? Except you want to go and specialize in networking. So you need to go and start from scratch and understand all of these things. But for our level and for this level that we are at, right? Just know some of these common ones and their port numbers. The good thing also is that when you want to set up maybe your security group, if you put in HTTPS, it will put in the numbers for you. So you don't necessarily have to cram all of them, so to say. Hope that is understood. All right. So both of them allows access to a web, either a web application or a website, whatever it is, anything that is sitting on the web, right? You need an HTTP or an HTTPS protocol, so you can allow both of them. Basically, SSH is for, mostly it is used by most Linux applications, right? It's a way to connect to your server securely. Maybe from your system you want to connect to the EC2 instance that you put on AWS. You can always use an SSH port, like ports, like one of the uh stuff I use for SSH most times is git bash, right? So for RDP is for Windows most times. So it's like if you check your system now, if you type RDP, you see remote desktop connection. It does the same thing that the SSH does. It's just that it's mostly used for Windows, and the port number is 3389. For MySQL, right, MySQL is 3306. Now all these ports are important, and we are going to see why as we go on. So please take note of this ones that I have put there that are common, basically. So now let's get into it. Understanding security groups, right? So what is a security group, or what are security groups? So security groups are like your firewall. We all know what a firewall is, right? It's something that you put as a security gate, right, before your house or something, right? So it kind of controls access to your instance. Now, security group acts as a virtual firewall. It's not a physical one that you can see, right, for your VPC resources, right? And it controls inbound and outbound traffic. I'm going to explain what inbound and outbound means properly in slides to come, right? So remember we said that your VPC is like a compound, right? Your subnet is like a building. So we can say that your instance is like a room inside that building, right? So it's like a room that is inside the building. So we can always say that the security guard is like a bouncer that is at that door, controlling those that can come in and those that can go out, depending on the rules that you have given to the bouncer, right? The bouncer will have rules that he's following, basically. Now, another thing to note is that security groups, which is SG or SGS, small letter S for short, right, can be attached to multiple instances at the same time, and multiple instances can be attached to uh, one security group at the same time, right? So basically, if you look at the picture here, right, you'll see how is like different traffics are coming, right? Now this is your EC2 instance that you have put there. This is the security group surrounding it. Now all of this traffic are coming. Let's say this is an HTTP traffic, this is an HTTPS traffic, this is an SSH traffic, all those protocol I was mentioning earlier on, right? This is an SSH traffic, this is an RDP traffic, then maybe this is a MySQL traffic. Let's just assume. Now, if the rule that you have put here is that only HTTPS and MySQL traffic are allowed in. So what the security group will do is that it's going to filter out, it's going to allow only these two that you have specifically stated in your security group that you should do what you should allow, right? And your security group are made up of rules that you set, and that is where those protocols I talked about come into play. Now, when you say inbound or outbound, what does it mean? Literally, is as simple as it sounds. Inbound is something coming in, right? Outbound is something going out. But there are things to note, right? So inbound is basically um, whether it is inbound or outbound, it means where the request is being originated from. Whether it is inbound or outbound, it simply means where that request is being originated from. Say, for example, now you have this laptop, right? On this laptop, you have typed in https semicolon / google.com, right? Which means you are trying to access the Google server, isn't it? So that kind of a request is what is an inbound request because it is originating from outside the instance to come into the instance. So an inbound request is something that is originating, the request is originating from outside of the instance, right, to go into the instance. So when a request is, let's say when you type that https semicolon / google.com, right, you've initiated a request, right? Now, what's when that request gets to the EC2 instance, what will happen? If it is a protocol that is allowed, that you have allowed in your security group rule, right, it will allow it to get to this EC2 instance and it will send a response back to you. And that response, the response you get is google.com will open up to you. That is the response of the instance to you. So that is an inbound. Is basically that the you have originated a request from outside of the instance and the instance gives you a response back. So that is an inbound rule, right? So inbound rule is whatever it's regulating access into the instance, is regulating access into the instance. So it's controlling whatever it is that is can go in to that instance. Controls whatever it is that can go into the instance. Remember, for an inbound rule, the request is originating from outside of the instance. Now, for outbound rule, outbound is going out, right? Which means that the request is going to be initiated from inside the EC2 instance, right? And then the response is going to be coming from outside the EC2 instance. You know, for inbound, the request is originating from outside to inside, and then the response is coming from the EC2 instance to the person that initiated it outside, right? But for outbound, it is the other way around. Outbound simply means that the request is being originated from within your instance to the outside world, right? And it is the outside world that is now sending a response back to the EC2 instance. And a typical example is maybe you have an application that is sitting on your EC2 instance and that application needs to update itself. Remember, we're talking about NAT gateway and all of those things, right? For the EC2 instance to be updated, you will need to access the internet itself, right? So it's one that is sending out, it's one that is initiating now. It is not from outside that the request is coming. So the EC2 instance or that application is the one that is reaching out to, let's say, for example, what's the name of this firewall that is very common? Give me the name of a firewall that is common. Uh, Maybe Windows. Let's use Windows firewall, right? For example, maybe it needs to update itself, right? So it goes to Windows site. It goes to Windows website. Once it goes to Windows website now sends a response back if it is what successful. Do we get that part? Can I move on? Do you understand the difference between inbound and outbound? Do we all get that? Windows Defender. Thank you very much, IMD. I was trying to remember that word. So do we get inbound and outbound? Can we move on? Okay. Happy. You say I should come again for which part? Okay. Tifa Connect understood. Okay. Christophane. All right. Okay. Okay. So everyone understands the difference between inbound and outbound. Please, it is important that you understand this because it's forming the basis for our going forward. So if you do not understand it, okay, app is clear now. All right. Charity say it's not clear. Which one is not clear? Which one is not clear? Charity. So let me just explain everything again as fast as I can because we have to be watchful of time today. So again, I said if I say inbound rule, basically what that rule is saying that it is guiding who can come in, right? Let's say for example, somebody has gone to go and somebody from outside. Now you have a visitor from outside, right? The visitor knocks on the door. The To you, it is what? It is an inbound request, right? Because the person knocking is trying to come inside. So it is an inbound. So the person says, Kokoko, is anybody at home? Right? Then it is now your job to do what? To respond to the person and say, yes, so come in. Or no, I'm not at home. Anyone you want to say, right? But that request is coming from outside. So an inbound rule is something that is coming from outside to the instance. So you are like the instance in this example, right? So an inbound rule is coming, it is originating from outside, right? Now, for an outbound rule is maybe by mistake, just an example, right? Please, maybe by mistake you logged yourself in. So you are now knocking the door. It is coming from you now. You are knocking the door. Please help me open the door. I want to go outside, right? So maybe somebody on the other side, outside of the instance, outside of the room where you are, will now say, oh, okay, I'm coming to open the door. Opens the door, or says, oh, stay inside. We're not opening the door for you. So for an outbound, the request is originating from the instance, from inside and going out. That is why it is called outbound. It is originating from the instance and going out, while for inbound, the request is originating from outside and coming into the instance. So for an inbound request, the response is from the EC2 to the person. But for outbound, it is somebody outside that is going to be responding to you, basically. Does that answer you? Think it was Charity. Is that clear now? Charity. Okay. Tina says yes. All right. So I want to believe it's clear for Charity as well. I want to hope that it is clear for Charity. Okay. All right. So I have more people saying yes now. Okay. So let's move on. Okay. So remember I talked about how security groups can be attached to more than one EC2 instance, right? And how um uh they can be attached to separate EC2 instance. So basically, one security group can be attached to more than one EC2 instance, and more than one EC2 instance can be attached to one single EC2 security group. So this is just an example of it. If you look at this now, we have security group A. Now this security group A is attached to this security EC2 instance, is attached to this EC2 instance, is attached to this EC2 instance. And you can have different one. They can be attached to one. So it depends on your need, basically. So in this other side, if you look at it, EC2 instance 1 is connected to security group A. EC2 instance 2 is connected to security group B. EC2 instance 3 is connected to security group C. So it is a many to many kind of connection. Many EC2 instance can connect to one um, um, security group. One security group can connect to many EC2 instance. Different security group can connect to different EC2 instance, just depending on your need, basically. I believe that's clear. All right, so components of okay, Charity responded that it's clear. All right, thank you. So components of security groups. So when you want to configure a security group rule, what are the components that you are going to AWS will require that you fill, basically? Number one is your protocol, like those things that I showed you at the very beginning. So your protocol, the port range or your port number, right? The type of traffic that it is, the source, and the destination. Now let's use this table to explain all that grammar that I just spoke. So when you want to set an inbound rule on the AWS environment, you first see where to tell you source. So source is basically, we said inbound rule is the originating request is coming from outside. Can you remember? Inbound rule, the originating request is coming from outside. So source basically means where is this rule coming from? So where am I expecting this rule to be coming from? For example, in this case now, right, this person has said we're allowing HTTPS rule. Remember, HTTPS is your secure web traffic, right? HTTPS rule. HTTPS is under the protocol TCP, right? And the port range 443. Please don't bother your head about this two. Yeah. When you put HTTPS on your security group, it's going to fill up this two automatically for you, except you want to customize it by yourself. Now, what is important is that I am expecting this HTTPS traffic to come from this particular CIDR block. Now, let's say that this CIDR block belongs to maybe a subnet, right? So what you have basically said is that this instance, so this EC2 instance that I've created must allow internet traffic from anything that is inside this subnet that the CIDR block is here. It must allow HTTPS into this EC2 instance as long as that HTTPS traffic is coming from this subnet CIDR block. That is an inbound rule. But for an outbound rule, remember your outbound rule is it is the EC2 instance that is originating the request. So which means that the request is going outside. So for an outbound rule, you have to what's the word now? Tell us the destination, right? So for an outbound rule, instead of saying the source, you tell us the destination, because outbound rule is it's coming from you, it's coming from the EC2 instance and going outside. So for this outbound rule that is here now, what this is basically saying is for every type of protocol, right? All type of protocol on all port ranges, which means that, for example, all of those protocols that I listed earlier on is going to allow every protocol that it knows, every single protocol that it knows, right? Is going to allow it. Now, where's the destination? To anywhere. I've said it before now. Anywhere you see 0.0.0.0/0, it basically means from anywhere. This simply means from anywhere. So this outbound rule is not restricting it. It means that the EC2 instance can send out an HTTP request. The EC2 instance can send out an HTTPS request. The EC2 instance can send out an SSH request. The EC2 instance can send out a MySQL request, whatever the traffic. Why? Because the rule here says that you should do what? Allow all type. And what's the destination? Anywhere. So you can send the request to another database, you can send the request to another subnet, you can send a request to the internet, whatever it is, right? Because that is the rule that you have put here. Inungo, do we understand this before I move on? Okay. All right. Thank you very much. Happy. Okay. So now let's look at let's use this, right, as an example. And I hope that this does not confuse us. Please just let me know when you're confused at any point, right? So we have in subnet A, we have three EC2 instances, right? In subnet A, we have EC2 instance 1, EC2 instance 2, EC2 instance 3, right? Then in subnet B, we have EC2 instance 1, 2, and 3. Now, all the EC2 instance in subnet A, remember I said all of them can be connected to one security group. It just depends on your need, right? So all of them are connected to this one security group. Excuse me. All the EC2 instance in subnet B are also connected to this security group. Please note that all of them are within the same VPC. Now, the first rule for subnet A is saying this is the protocol. Now, another thing to note, and I think we're going to go there, is that one of the features of a security group is that you can only allow, you cannot explicitly deny. So all the rules you set in a security group is to say allow this. So you cannot say, oh, deny this, right? You can't say deny. You can only say allow. So in a security group, you explicitly allow, but it does what? Implicitly deny. Implicitly means that even though you did not say it, you do not put it there. As long as I don't see an allow, I'm going to deny, right? As long as I don't see an allow there, I'm going to deny. That is implicit, right? But explicit means there's a written rule there. You wrote it down, allow or deny. But for security group, you cannot deny. You can only explicitly allow. So once you don't allow something here, right, the security group would automatically assume that you want that thing denied. So once you want any traffic allowed, you have to come and specify it that it is what allowed here. So now let's look at the security group um rules that we have here, right? The protocol is what? TCP and port 22. Now this type of protocol is an SSH protocol, right? That's one that has port number 22. Now, basically, what this means is that what this is saying, allow SSH traffic to all these any instances that is within the subnet A, because all of them are connected to this, right? So allow SSH traffic to enter into, because this is an inbound rule. Remember, inbound rule is the one that you specify the source, right? Well, outbound rule is where you specify destination. Please let's take note of these things. So this inbound rule now is saying allow SSH traffic to come into these instances in subnet A. But from where? That SSH traffic must be coming from this CIDR block. It must be coming from within this network address. So any network address that is outside of this one that you have specified is going to block it, because you have specified a specific address that you want that traffic to be coming from. So this again is saying allow SSH traffic to come into the instances that are in subnet A, but that SSH traffic has to be coming from this particular address. That's the first rule. The second inbound rule now is saying allow all traffic coming from the subnet A cider. Now, this rule here, this second rule, is basically saying that what? Every of these EC2 instances, they should be able to communicate with each other. So if this one wants to send an HTTPS or an SSH or a RDP protocol, whatever it is, to this one, it can go through. If you do not specify this, these three instances will not be able to communicate with themselves, even if they need to. It is not every time that EC2 instances need to communicate with themselves. But if for instance now, on this EC2 instance, you have a database, on this one you have an application, right? And you want that application to communicate with the database that is here. If you don't specify this rule, both of them will not be able to communicate. So what this rule here is saying that allow all traffic between all the subnets that are within this subnet A. So that's why whatever it is you're going to put here is going to be the cider block of this subnet A. Maybe it's your 10.0.1 and .0/24, maybe, right? So it's going to allow any type of traffic, right, to come into any of these instances as long as that instance is within this subnet. Do we get the first one that I just explained? Christophine, did you join us from the beginning? Did you join us from slide 2? Because I showed us what a TCP is. TCP is a type of protocol. Okay, so Debbie, please let me know where you want me to explain again. All right, this one I know is going to be a very tricky one. Very tricky. So you have to like pay attention, like very, very well. So don't be distracted. There are things that can confuse you, right? So Christopher, let me okay, I said TCP is a kind of uh a protocol, right? I've already listed some of the common type of protocols that we have, basically. The rule of the source is a bit confusing. Okay. All right. So, happy. Where should we go back to? Okay. Now, can we see this particular slide? Remember we had discussed this slide, right? Can we all see this new slide that I am on? This old slide that we had discussed before. Can we see it? Okay. All right. So thank you. Now, remember I talked about how an inbound rule means that the request is coming from outside, right, into the EC2 instance. That is what an inbound rule is. The request is going to be originating from outside. So for this kind of, let's say this example now, this inbound rule, what is basically saying is that the source is going to be from this system. The source can be from anywhere, but let's say we want to restrict it. Let's say, for example, I have put an application on EC2 instance, right? But I only want my laptop. I only want my laptop to be able to connect to that EC2 instance from uh, the internet, from the web, right? I want only my system. Now remember, every of our system also they have their own IP addresses and all that, right? So what I will do now is I'm going to say this EC2 instance, so the inbound rule I'm going to put in the security group would be to allow HTTPS. Remember, I'm going through the web, right? I'm going through the web. So allow HTTPS protocol, right? On port number, HTTPS port number is 443. Again, you don't have to cram all these numbers, right? You get to know them over time as you use them. You get to know them off. and but some of these ones are some of the very common ones. So let's get back to our rule. So inbound rule here will be that what allow HTTPS protocol, right, on port 443, because that's the port number for HTTPS, right? But where is the source? Which source? Should I allow anywhere, or am I restricting it? If I want to say allow HTTPS from anywhere, then my source will be that 0.0.0.0/0, because that is what means anywhere. If I put 0.0.0.0/0 in my source, it means that this EC2 instance, right, would accept HTTPS traffic from anywhere, from my laptop, from another person's laptop, from somebody in China, from anywhere. But let's say for security reasons, I'm not yet ready to put my application out there. I'm still test running it. So I only want only my system's IP address to be able to connect to that EC2 instance, right? So my rule now will be that allow HTTPS traffic, right, on port 443. But when I now get to my source, instead of putting anywhere, I would now restrict that source to my system's IP address. So basically saying that only allow HTTPS traffic to come into you this EC2 instance, here word, only allow HTTPS traffic to come into you if that HTTPS traffic is coming from Ifeoluwa's laptop, because I've already put Ifeoluwa's laptop's IP address there, right? While for this second one, what I'm going to be saying, instead of source, remember, it is no longer a source because the traffic is now, or the request is going to be coming from the EC2 instance now. So instead of source, we are going to be talking about destination. So for this one now, I can now say that, oh, allow HTTPS request, right, on port 443. So where will my destination be? My destination can be anywhere, but because I'm restricting into my laptop because I'm still test running. So my destination will now be my laptop's IP address again. So bringing it back here, where were we? Okay, bringing it back here, you can assume that this one here, this address here, is my laptop's CIDR block. You can assume that, right? So using this as an example again, now we can now say that what this rule here is saying, that remember port 22 is what SSH. So what this rule here is saying, that allow SSH traffic to come into all of these EC2 instance that are connected to this security group. Remember, the three of them are connected to this one security group. So which means that it's going to allow SSH traffic to come into any of these EC2 instances, but make sure that SSH traffic is coming only from Ifeoluwa's laptop's CIDR block. Make sure that it is coming only from Ifeoluwa's laptop CIDR block. Remember, Ifeoluwa's laptop is not sitting in this subnet. Ifeoluwa's laptop is sitting somewhere in a redemption camp, right? So it is not within this subnet. Do we get this one now? While this second one now is a rule that you say on a normal day, on by default, right? All of these instances, by default, these three instances cannot communicate with themselves, even though they are within the same subnet, right? They can't communicate. And I was saying communication is probably needed, maybe where, for example, you have a database in this one, and then you have an application in this one. And this application that is in this instance needs to talk to the database that is here. Maybe it needs to get data from this database. Ordinarily, they won't be able to communicate because there's no rule that is allowing them to communicate. But this second rule here now is saying allow every type of protocol, whether it is SSHO, or it is RDPO, or it is HTTPO, or it is HTTPL. So allow it, as long as that traffic is coming from within this subnet. So basically, you can have more than one rule, right? Because different rules will apply to different things. There are some security groups that are up to 15. Shey you get? So this one has just two rule at the moment. Rule number one is that allow only, because it specified the port, allow only SSH traffic come into these instances, any of these instances, but that SSH traffic must come from this particular ID, from this particular CIDR block. Let's say, for example, my laptop, right? So now, if my laptop now wants to do an HTTPS connection to the EC2 instance, it will not allow it. Why? Because it was only an SSH traffic that was allowed. Do we get that? Is that clear? Do we understand it now? There's still another thing in front that we'll use to um explain more as well. But don't get confused so much. We'll take it as slow as we can. As slow as we can this evening. Okay. So we're good to move on. All right. Thank you. Thank you, everyone. Okay. So for the outbound rule, like I explained that one. So this one, instead of restricting it to only my laptop, right? I'm saying allow, as long as the network is, as long as the traffic is coming from this EC2 instance, let it go out. As long as it is coming from this EC2 instance, any of this EC2 instance, let it go out. That's basically what this means. So allow any type of traffic, and let the destination be not only Ifeoluwa's laptop. Let the destination be anywhere. So if this instance wants to get updates from China, it can go to China and go and get the updates, because I did not restrict it, basically. So the same thing here, the same thing happens here too. Okay, so our time is fast spent. Yes, please, you can drop your questions after today's video. Yes, please. All right. So characteristics of security group, right? Number one characteristics is that it is stateful. Is that it is stateful. Now, what does it mean to be stateful? It means that if I allow an inbound request, right? If I should allow an inbound request, automatically the outbound response will be allowed. So basically, it's saying that if I should say, oh, Tayo can come and knock on my door. Anytime Tayo knocks or Tayo comes in, when Tayo wants to go out, Tayo can go out automatically. That's so it means that if the bouncer now, remember we said security groups are like bouncers, right? You have come and the bouncer has checked, oh, Oga say I should allow you to enter. So you have entered, right? He has checked you, you have entered, because there's a rule that says enter. Now, you've gone to deliver the message or whatever it is that you came to do at the party. You are collecting your response and you have to leave the party now. When you are going out, the bouncer will not stop you again. It will recognize that, oh, this person was allowed in. So because this person was allowed in, the person can be allowed out as well. That's the meaning of stateful. The bouncer will remember. Bouncer will remember that, okay, Otiwole Tele, this person has already entered. The person can go out, right? So it will not need to start checking you again, because he knows that for me to have allowed you in, then you are allowed to go out, basically. So that's the meaning of stateful. Another characteristic, and I'm going to explain it again with a diagram in front, right? Another characteristics of security group is that it is allow only. I already mentioned it before. You can only set allow. You cannot set and explicitly deny. So all those rules we were setting, you cannot say, oh, deny HTTPS traffic from Ifeoluwa's laptop. You can't set it, right? What it's you can only do is to say, oh, allow from Ifeoluwa's traffic, or allow from everywhere, or allow from Ifeoluwa's traffic and Happy's laptop, right? That's what you can set. You can't tell it to deny. So for a security group, there is an explicit allow, but an implicit. Explicit allow, implicit. Implicit means that if you say allow HTTPS traffic from Ifeoluwa's laptop, you specified only allow HTTPS. The security group would assume that since it was only HTTPS that you specified, automatically is going to block every other one that you did not specify. So that is an implicit deny. Because you've only specified allow HTTPS, automatically it will deny every other one. So if I now come back to say, oh, allow HTTPS, I now put another rule and say also allow SSH traffic from Ifeoluwa's laptop. So it's going to allow HTTPS traffic, it's going to allow SSH traffic from my laptop to the EC2 instance, but it's going to block any other traffic that is coming from my laptop. Why? Because it did not see an explicit allow. So it operates with an explicit allow and an implicit deny, but there's no way you can set that, oh, deny Ifeoluwa's laptop. You cannot set that kind of thing, right? Now, another characteristics is that by default, when you go to your AWS environment, right? Let's say, for example, you create an EC2 instance and a default security group is created for you. By default, the security group inbound rule will block every incoming traffic. By default, it does not allow any traffic to come in, whether it is HTTPS or SSH by default, until you now go and start adding rule by yourself. So a security group by default has no inbound rule. And once it does not have an inbound rule, what does that mean? It means that it's going to what? Block it automatically. Remember, we have said it follows an explicit allow. So if you did not put anything there to allow, it will automatically block everything that is coming into the EC2 instance. So it has an explicit block all by default, block all incoming traffic, but it allows all outbound rule, which means that by default, a default security group, before you start adding your own rule, right, or changing or modifying the rule, by default, that security group will block every inbound rule, every inbound traffic, and allow every outbound traffic, which means that if the request is originating from the EC2 instance, it will allow it. But that something is coming from outside to the EC2 instance, it will block it by default. So those are the three characteristics, major characteristics of a security group. Now, let's explain what stateful means, right, with example. Now, remember I said, uh, what if the person still... Don't worry. Teju, no, no, the person is not stealing anything. I noticed when configuring a smart to use specific postures on accessibility as 8080. Yes, smart. Why 80? So again, these are already specified rule. I'm not the one that named them 80, right? And unfortunately, I'm not specializing in networking. So I cannot answer you why they decided that it was 80 they were going to use, right? So a group of people do what they regularize these things, right? These numbers are regularized by bodies, so to say. So we know that, and 8080 is usually a local, if I remember, is your local port. Is like your laptop port, basically, or your local system phone or whatever it is. That's like your laptop port or your phone port, whatever it is. But it's not me that gave them the 80, right? So I don't know what their reason for doing that is. Maybe by the time I decide to, if I want to specialize in networking, I can now go and start finding out why it was 8080 and not 8020 or 2080 or 4060, right? So now, hope that is understood, Levina. Okay, so let's explain what I meant by stateful, right? Remember I said stateful is that it allows, once the bouncer checks you and you come in, it will allow you to do what? To go out, as long as it's the same thing that was allowed, right? It will allow you to go out. That is stateful. Now let's use this to explain it. So on your security group, right, you've set a rule that allow all traffic. You set an outbound rule, right? You said Outbound rule is what? Allow all traffic. Remember, outbound rule means that the request will be originating from the EC2 instance. And in your inbound rule, you did not now set anything. In your inbound rule, you did not set anything. But in your outbound rule, you said allow all. Now, your EC2 instance now has requested or initiated an HTTPS traffic. HTTPS is browser. Maybe the EC2 instance needs to get an update, right, from the web, from maybe Google or from Windows. So it has gone online. It has sent an HTTP traffic outside of it. So because there's a rule that says allow all, so allow all means any traffic. So it has sent an HTTPS traffic to, let's say, windows.com. Now, it's trying to get an update. Windows.com has to respond to it that okay, maybe downloading or it's updating it or whatever it is. That is the response to his request, right? By default, even though there is no rule here, even though there is no inbound rule, because there's a rule that already says allow all, and the request is what originating from EC2 instance, there's already an allow all rule. The request is originating from here. Is going to allow the response to this request automatically. So it will allow windows.com to give a response to the request that the EC2 instance had sent to it. It will not need to start checking, did they allow windows.com? It will not check, because if EC2 instance has already initiated a request to windows.com, it recognizes that okay, this was an HTTPS request. So when Windows is sending a response back to the EC2 instance, an HTTPS response back, it will automatically allow it. So stateful is simply that since the rule allows all outbound traffic if an HTTPS request originates from the instance, even though there is no rule for the inbound, the security group will allow an inbound response. Remember, it is a response, right? Remember that it is what? It is a response. Please give me 1 minute. Someone is okay. I needed to quickly reach out to someone that was trying to call me. All right. So this is the first example. Now let's look at this example. Now this example is what? The same rule. The same rule. There's an outbound rule that says allow all, and there's no rule in the inbound rule. You did not set anything, right? And we said that if you did not set anything, it means that it will automatically block everything, right? Now, this first example, the request is coming from EC2 instance, which means it's an outbound request. That is why it was what? It was able to go. Now, this second one, it is somebody from outside that is trying to originate a request to the EC2 instance. So this is not a response. It is this one that is trying to originate. Remember, that was why I said that we need to understand that first diagram I showed about inbound and outbound, right? Because this request now is being originated from here, and there is no rule that allows it, is going to block it. This traffic is not going to get to this EC2 instance because this is not a response. If it was the EC2 instance that initiated a request to the HTTPS client, right? Because there's already a rule that allows for the EC2 instance to be able to send out outbound traffic. It means that whatever the website will be sending back to it is a response to the EC2 instance. But the EC2 instance cannot initiate. Why? There is no rule that is here. So once there is no inbound rule, right, it means that outsiders cannot initiate a request. That's why this request is what is being blocked. That's why it's not allowing it. Do we get that? What if the website has EC2 instance? Yes, please. I think we can go for our attendance now. 883 and Josiah. Yeah, we can go for our attendance. So while we're doing that, let me be answering. Patient says, what if the website has EC2 instance? The EC2 instance is not sitting in your subnet. So the fact that it is, even if Google, right, is putting their Google server or their application on an EC2 instance, it is not your EC2 instance, right? They have their own rule that is also governing them. So it is not by default. Remember that was what I was showing in that example where we had three EC2 instances. The fact that those three EC2 instances are even inside the same subnet does not mean that they will be allowed to communicate with each other. Does not mean that by default it will just allow everything to be flying if you don't put a rule that, okay, allow traffic from this EC2 instance. Hope that answers your patience. Hope we've understood this so far. So good. The attendance link is also opened. Please let's fill our attendance form. So, but hope we've understood this stateful and the stateful characteristics of it, the security group. Hope is understood. Levina, fast, fast, fast people. Levina and happy. People are fast, fast people. Okay, so Neil Alawa understood. All right, please, we need to understand these things. Oh, we need to understand it. All right, Tina, done. Okay. I think we have about 5 minutes for the attendance. We've done about 2 minutes already, if I'm right. We've done about 2 minutes already. Data analysis is bringing you here, okay? Abego. Pages of motherhood. How were you transported from data analysis to cloud computing? Can stay with us, so we don't mind. Okay, so I think about 1 minute more, if I'm right. About 1 minute more for the attendance. I'm not saying you said partially. Okay, I'm not happy. Okay. I'm not happy. Are you responding to pages of motherhood that inbound rule, no access? There's no access granted. Oh my god, oh. I'm not happy. So you're setting inbound rule to block pages of motherhood. Ah, there is God. Okay. All right. So I think it's 8:06. I think we can get back to it. Idiri, do I have a go ahead? Can we get back to our class before people pursue me by 9 o'clock? As in, I'm not happy. She's not playing at all. She took her to cloud computing straight. But no, you are not nice. So somebody missed that way from data analytics, and you just confused that the more. Oh God. All right. So okay, I think we can move on now. All right. Please, for those that need the attendance list, again, it is in the description. Just check under the live video where you see 50 something people watching or something people watching. Click on more. You will see the write up. If you're using your phone, click on more. To open a text, click on more again. Then you see where they say click here for your attendance, blah blah blah. Click on that link, basically. All right, so let's get back to it. It's 8:07 already. Okay, so we've understood stateful conversation. Stateful is basically that if you set a rule, to say allow, the rule is allow a follower to go out, right? That's an outbound rule. So from this house, allow a follower to go to the market, right? So a follower goes to the market. When a follower is coming back, they will not need to start saying, yes, who are you? Who are you? Who are you? They will automatically allow me to do it, to enter. Why? Because the request was initiated from inside the house, right? And the rule is that allow somebody from inside the house, right? Allow Ifeoluwa from inside the house to do what? To go out, right? Now, if the rule is allow Ifeoluwa and Ayo from inside the house to go to the market, right? It means that the security people, the bouncer at the door, when I'm going, they will allow me to do what? To go out. They will allow my sister to go out because that's what the rule says. And when we are coming back, because we are coming back as a response to the fact that we were sent on an errand, right, from inside the house. Remember, it's an outbound route. It automatically allows us to come in with everything we bought from the market. But the only rule that was set in that house is that allow Ifeoluwa and Ayo to go and buy something from the market. If Yemisi, right, is now coming from outside. She's not a member from the house. She just came of her own free will, went to the market to do shopping, and then now brings the goods to say, oh, I want to give this so to mommy fell, right? What will happen? The bouncer will say, carry yourself and be going. Why? Because the request was not originated from inside the house. Because the only rule is what? The only rule that was attached to that room, right, is that allow Ifeoluwa and Ayo to go out. There was no rule that says allow people from outside to do what? To come in. So if there was an outbound rule that says allow Ifeoluwa and Ayo to go out, and then there's an inbound rule that says allow people from outside to come in, it means that the bouncer will allow me and Ayo to go out, and it will also allow us to come in, right? And then it will allow people from outside to do what? To go out, because now I have added a rule that says allow people from outside to come in. So basically what I'm trying to paint here is for a stateful characteristics of the security group allows that if it is a response from the rule that was allowed, it will allow you to come in. If you have put an inbound rule that allow Yemisi from Mommy Shalewa's compound to come in, right? That's an outside, it's an inbound rule, right? The person is coming from outside that house to that house. So when Shalewa is coming, to allow Shalewa to to allow Yemisi to come in, right? And when Yemisi is going, because there's already a rule that says allow Yemisi to come in. When Yemisi is going, the bouncer will not stop her. It will allow Yemisi to do what? To go out, because the bouncer will remember that, okay, there's a rule that says let Yemisi come in. So if there's a rule that says let Yemisi come in, it means that Yemisi can go out. If it is an outbound rule, the rule is saying let Ifeoluwa from inside this house, so let her go out to the market. If I go out, the bouncer will not stop me, right? Because there's a rule that already says let Ifeoluwa go out. And when I am coming back, the bouncer will remember that, oh yes, Ifeoluwa was from this house. It was Ifeoluwa was sent from inside this house, so let her come in. Do we get that? Does that explain it better? Do we understand what the stateful is? So stateful is basically that it remembers. It remembers that this thing. But if that rule was not there, Ngwano, it cannot, it cannot. Um Comfort, so sorry. Okay, so let's quickly move on. Let's move on. So this part, this picture is basically saying that you can plan your security group, right? Remember we said more than one EC2 instance can use one security group, right? And how do you choose? Say for example you have two EC2 instance in your public subnet. A public subnet means that they need to have access to the internet, right? And the two instances are both web servers. So majorly they'll probably need the same rule, maybe the same rule of allow HTTP traffic, allow HTTPS traffic, inbound and outbound, right? So you can apply the same security group to the two of them. Now, you go to the private subnet, you have a database and you have an EC2 instance. Both of them are in the private subnet, which means that they don't have access, they will not have direct access to the internet, right? You can attach the same security group, but it might not be so wise. You can create a separate security group for this EC2 instance, right? You can create a separate RDS group for RDS security group for this database. Just as simple as this is just to show that you can group different things if they need similar rules. You can group them together and just attach one security group. And if you feel like this security group cannot work for this one, or remove that one and give it its own separate security group, basically. All right, so let's quickly move on to NACLs. So what is NACL? NACL is network access control list. Network access control list. That is what NACL is. Network. So for those that said they could not find the link, attendance link, I think that's what Ediri just posted again. So if you've not filled, kindly do so. All right, so network access control list. Now, if you remember at the beginning, I said your security group is an instance level firewall, right? Which means that your security group is going to be attached to your EC2 instances, whether it is one or two or 10 that you want to attach it to. Your EC2 your security group will be attached to an EC2 instance. So security groups are instance level firewall. Now, your NACLs, network access control list, they are subnet level firewall. So if we say that your EC2 instance is like a room in a building, right? It's like your own in a building of apartments, different apartments in that particular building, or different rooms in that building. Let's say like an hotel room, for example. Now, in that hotel building, there are different rooms there. So your EC2 instance is like the different rooms that are there. Security group is like the bouncer that is standing at the door of each of the rooms, right? The bouncer can be securing more than one room, right? More than one room can use the same bouncer. That's like your security group. Now, the NACL is that building itself, right? It is the security guard that is standing at the entrance of the building before you even go into the room. It's one that is going to stand at the entrance of the hotel and say, yes, how may we help you today? Right? That is what the NACL is. So the NACL is a subnet level, so it stands or it is attached to the subnet, right? It's one that controls who can leave or what can enter into the subnet. And what are the key features of the NACL? Like I have mentioned already, it controls traffic at the subnet level, not at the EC2 instance level, right? It controls traffic at the subnet level. Number two is that what? It's um it's works with ordered rules. So if you have I'm going to explain better with diagrams later on in the slides. But if you have like 1, 2, 3 rules, it starts following the rule number one, rule number two, rule number three, basically. Then the third feature of NACL is that you can configure both allow and deny. Unlike the security group that I said, you can only explicitly allow something. That is the only thing you're allowed to set. You cannot explicitly say, oh, deny this particular traffic. You cannot. It's just that when you allow something, if the security group sees that you allowed this thing, it will automatically assume that any other thing that you did not allow, you are denying it. But for NACL, you can say allow Ife and deny Ayo, or allow Yewande and allow Ayo. You can specifically say it. You can explicitly. It is no longer an implicit now, right? You can both explicitly say allow and you can explicitly say deny. Now, what are the characteristics of NACL? Opposite of security group. Unlike security group that is stateful, right? NACL is stateless. So NACL is like an alakogbagbe security guard. Used to forget. So for every, unlike the EC2 instance where the security group were saying that if you give a rule, an outbound rule that says allow Ife from inside this house, right, to go out to the market, because there's already a rule that says allow Ife to go out. When Ife is going out, the bodyguard will not stop, the bouncer will not stop Ife, right? And when Ife is coming back from the market, the bouncer will also not stop Ife. Why? Because he already sees that, oh, Ife was allowed to go out, right? There was a rule that says Ife should go out. So once, if there's a rule that says Ife should go out, there should be a rule that will allow her to come in automatically. It just uses his common sense, right? But for NACL, is that over worrying security person that as you have entered, you went out now. As you're coming back inside, it's checking you again. That is an NACL. So for an NACL, if you say allow Ife to go out as your outbound rule, right? You must also specify in the inbound rule that allow Ife to come in. If not, as you have sent Ife out, Ife is not coming back inside. Ife is going to be stuck outside. So unlike the security group that once you allow something, it would also allow the response of that thing, right? It will also allow the response of that thing. But for NACL, if you allow something, whether it is inbound or outbound, it does not automatically allow the response. You have to go and set a rule to say allow. If you have set an inbound rule, right? An inbound rule is that allow Yewande from Iyashalewa's compound to come inside, right? To bring something from the market for us, right? And then Yemisi from Iyashalewa's compound now comes and he enters with the market things that he bought. Now Yemisi has to go back to her house, right? If you did not put a rule that Yemisi should go out, Yemisi will not be able to go out. Oh, you have adopted one more child. That's the meaning, right? So basically, it's like if you go to a website and then you type google.com, for example, right? And there's a rule that says, oh, allow a HTTPS request from, an inbound HTTPS request, which means that the request is generated from outside the instance, right? So I've typed google.com. That is, I'm originating the request. There's a rule on Google's instance, wherever it is sitting, that, oh, allow HTTPS traffic. So it allows. But now it's supposed to give me a response, right? The instance, their website is supposed to give me a response by now opening up the google.com page to me. But because maybe Google forgot to add an outbound rule that allow HTTPS traffic to leave the instance, even though it is a response to what was originated, the NACL will not allow it. So it means that NACL is what? Is stateless. Also, like I also mentioned as a key feature, is that what you can set both an allow and deny rule. Number three is rule evaluation. Remember I said it evaluates your, if you have five rules, it will evaluate them in numerical order. So one of the things that's one of the component of an NACL rule, as we will see in front, right, is that it will have a rule number. Now, unlike the security group, remember I said that a default security group, the one that you've not added any rule to, by default, security groups that are created, right, by default, security group would block every inbound traffic but allow every outbound traffic. So security group will not allow visitor to the house, but it will allow people from the house to go out by default. That's security group. Now, for NACL, by default, the one that comes, that AWS gives to you, you are not the one that went to go and create the NACL yourself, right? Default NACL that AWS has, once you create a VPC, AWS is creating NACL for you, right? So that's default NACL, which will allow Taja Teron, everybody can come in, everybody can go out. That is the rule that comes with it for a default NACL. Anybody can come in, anybody can go out. But when you now go and create an NACL by yourself, so you are creating a custom NACL, it's not the one that AWS gives you anymore, right? You are creating a new custom NACL. That new one, the default rule that will be on it is to block every traffic, both inbound and outbound. It will block everything until you now had rules by yourself. So the one that AWS gives to you, which is the default NACL, right? The rule on it is that it allows both inbound and outbound traffic, every traffic possible it allows. But when you create a new NACL, right, you've not yet added your rules to it. By default, it's going to block every inbound and every outbound. So visitor cannot come, you too, you cannot go out. That's simple as that. Hope um hope that is understood. We have kidnapped Yemisi. It's not also. It's our mommy that forget to set the rule that Yemisi can go out. All right. Yes, yes. I remember Tejiri was saying that somebody can steal something. Yes, if it is with security group, you can steal, but NACL, we check your bag very well. You cannot steal anything. All right. So now, how does NACL, when I said it does evaluation, it follows the rule in numerical order. Let's look at what that means, right? So this is an example of an NACL rule, right? Did we talk about the uh sorry, give me a minute. Oh, did we miss that? So the component of NACL rule is the same thing as the component of your security group. The only difference in this case is that this one has a rule number attached to it. So you have to put a rule number. Now, let's look at this rule first and analyze this rule. Rule number 10 is saying that allow, remember I said in this one you can allow or deny, right? So rule number 10 is saying allow HTTPS traffic, right? Again, HTTPS is on this ports, right? Allow HTTPS traffic from, so this is an inbound rule. Remember I said inbound rule is something that is coming from what is originating from outside. So basically this is saying allow HTTPS traffic into this EC2 instance from anywhere, right? 0.0.0/0 is anywhere. So allow, that's the first rule that we have here, rule number 10. Now rule number 20 says also allow SSH traffic from this particular IP address. So this particular IP address is maybe my own laptop, right? So this rule is saying allow SSH traffic into this EC2, into the EC2 instance, that the subnet rather, into the subnet that this NACL is attached to, right? Allow SSH traffic into that subnet, but that SSH traffic must be coming from Ifeoluwa's laptop's IP address, right? Now, the third rule is saying that allow deny rather. It's saying deny all type of traffic wherever it is coming from. Deny it. Don't allow anybody to come in, right? That's what these three rules that are in our NACL is doing. Now, if a traffic is coming into NACL, how will NACL treat it? How will the security guard? This is the rule that the management has given the security guard, right? So if the security guard now wants to allow people to go in, or what is he going to do? So what he's going to do is this. It will first start from rule number 10. Remember, it is going to check the rules in numerical order. So it starts from the first rule, rule number 10. And it says, okay, rule number 10 says allow HTTPS. So if an HTTPS traffic is coming from anywhere, it will allow it to enter into that building, right? You know, we said subnet is like our hotel building, right? So it will allow HTTPS traffic to enter. Why? Because it has seen a rule that says allow. It will go forward and say, okay, SSH traffic is coming from Ifeoluwa's laptop. Do they allow SSH traffic to check? Rule number 10. Okay, rule number 10 says HTTPS. Okay, to check the second one. Rule number 20 says SSH. What does it say? It says allow. From where? From a first laptop. Okay, is this a first laptop's IP address? Yes. Okay, so it allows it. Right? Now, it will not check. Somebody is coming into the EC2 instance. The thing is not HTTPS, and it is not SSH coming from Ifeoluwa's laptop. Maybe it is SSH that is coming from Iwande's laptop, right? So it's going to check. All right, what rule do I have? Rule number 10 says allow HTTPS. Okay, this is not an HTTPS traffic. Rule number 20 says allow SSH traffic, but it says allow only from Ifeoluwa's laptop. So it will check. This traffic that is coming, is it SSH? Yes. Is it coming from Ifeoluwa's laptop? No. Okay, so it will move on. Rule number 3 says deny every traffic. So once it gets to this last rule, it will automatically block that, because this rule says what? Deny. So any other traffic apart from these two that has been allowed, because of this third rule, is going to deny it. So that is how it evaluates. Now let's look at another example. Now, this is another example. If we look before, I want you to look at the first one and then look at this second one, so that you will notice the difference in the two rules. This is the first one, right? The first rule, um the first rule is allow HTTPS. The second rule is allow SSH from a specific IP address. The third rule is deny every type of traffic from anywhere. That is this first example, and we have explained it. Now, this second inbound rule example, rule number 10 says deny any type of traffic coming from anywhere. Deny it. That's rule number 10. Rule number 20 says allow SSH traffic into the instance as long as the SSH traffic is coming from Ifeoluwa's laptop IP address. Rule number 30 says allow HTTPS traffic from anywhere. Now, let's now assume CC SSH is coming from Ifeoluwa's laptop. What will the security guard do? He's going to block her. Why? Because the first rule that is here, as he's checking his rule book, the very first rule he's seeing is what? Deny. So it does not concern him whether the rule is after it. Maybe there's number 10. On number 10, they say allow. Or on number 2, they say, oh, allow. It does not concern it again. Because this deny rule is coming first. It's going to block every access. Every kind of traffic. It will block it. Why? Because it follows order. So that is why your rule number is what? Is important when you are configuring your NACL. That is why your rule number is important. So you don't want to put this kind of a rule as the first rule, because once this is the first rule, There's no magic you want to do. Nothing will enter inside this building. No. Even if you are the vice president child coming from Tinubu's office direct, you're not going to enter into that hotel building. Why? Because the first rule that is seen is what? Deny everybody, wherever it is they are coming from, whoever it is that they are, deny them. So even though maybe Tinubu's child is SSH, is coming from presidential villa, right? This IP address, even though he's on the second rule, because the security guard has seen the first rule, nothing concern him again, right? But for this one, this other one, there's a rule that says deny everybody, oh, but on top of it, so it goes in numerical order. He checks the first rule. Does this first rule apply to this thing that is coming? Oh no, okay. He checks the second rule. Does it apply to this thing that is coming? Yes, okay. He allows, right? But because the second one, the very first rule he's saying is what? Is deny everybody, is denying. Now, if we are to rearrange this rule now, right? Let's say we put this number 2, this number 20 rule, we'll put it first. And then we'll now move this number 10 rule to second. So we are saying number 10 rule is now allow SSH, right? From Ifeoluwa's laptop IP address. And then number 20 rule is now going to be deny all IPv4 or all traffic, right? From anywhere. So now SSH is now coming with her beautiful self. Now, because SSH is now going to be the one that is on top, what will happen? It will allow her to enter because he's seen it first. He's seen that, oh, they said allow, it will allow her to enter. Now, if HTTPS2 is now coming from wherever it is, Tinubu's child is coming from presidential villa, right? Is the HTTPS traffic. He's trying to enter into the hotel building. Now, the security guard will first of all check what is rule number 10. Rule number 10 says allow SSH, right? It has allowed. He now checks number 2. Remember that I said we have swapped these two, right? He now check the number 20, the second rule. The second rule now says deny. Oga, sorry, you cannot enter. So it follows that numerical order. Hope that is understood. Hope that is understood. Yes. So if we rearrange that rule and we put the deny to be in the second rule, and we put allow SSH first, and deny is in the second rule, and then allow HTTPS is the last rule, it will allow SSH, but it's going to deny HTTPS. Why? Because the second rule is saying deny all, so it will not bother to go and check the third rule again. It depends on what you want, but it will not be advisable that you put deny all as first or second. So you can always go and rearrange your rule number, right? If you check that, oh, maybe at this point it was only HTTPS that I want, so you put HTTPS, you put SSH, and then you now put deny all as number 3, right? Which means that any other traffic that is coming, maybe like RDP, now it will deny it. But later on, you now realize that, oh, I actually need an RDP traffic to come into the EC2 instance. You can now go and add the RDP before that deny. Just make sure that it comes before the deny, because if it should see deny first, it's going to deny. The same thing as if it sees allow first, it's going to allow. All right, so I'm glad that we're all following. So remember I said NACL is stateless. This one should be quite easy to understand, right? Because I already mentioned, we already explained what stateful is with security group. So again, our outbound rule says allow all traffic, right? But we did not set any inbound rule. Giving an example, this rule is saying that in this hotel or in this hotel building, the rule the management gave to the security guard is what? Allow everybody to come out of the hotel. Anybody can come out of the hotel. Anybody at all. But then the inbound rule, you did not put anything. You did not put anything. If it was the case of security group, once you say allow anybody outside to go out of the hotel, if those people should go out, is to also allow them to do what, to come back in, right? Because it remembers their face that, oh, this person left us. But for NACL, it is stateless. So if it says allow everybody to go out, which is your outbound rule, but you did not put any rule about inbound, you did not say anything about anybody coming into that hotel building, what will happen? So let's now assume again, Tinubu's child, right? Tinubu's child is coming into this hotel building. Oh, sorry, I think I mistakenly um put this, right. So it's supposed to be a situation of Tinubu's child, right? This is supposed to be allow all inbound, right? But then you did not put anything for outbound. I've been around. I'm so sorry. So just look at this like this. This is supposed to be inbound rule. This is supposed to be outbound rule, right? So Tinubu's child is coming from presidential villa, right? Since we say allow, it will allow it to go in. So now Tinubu's child have finished in the building, in the hotel building, right? He has finished talking to the management and everybody. He now wants to go. But in the rule that management gave security guard, he only said allow people to come in. They did not say allow anybody to go out. So to tell Tinubu's child, Oga, sorry, we cannot allow you to go. Like who was saying it then? That said we kidnapped the MEC, yes. So they are going to kidnap Tinubu's child. So and lock him up inside that room. So for Tinubu's child to be able to leave that building, right, you need to do what? Now set the rule to say in the rule, allow everybody to go, allow everybody to come. That would be the only case. If the security guard does not see a corresponding rule that is allowing them to leave, they are not going anywhere. Do we get that? That's basically what the stateless blah 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 means. Do we get that? Ten does not come after 20. 10 comes before 20. So whatever rule comes first, right? Or not happy. It is 10, 20, 30. So it's going to check it. It's like you're having 1, 2, 3. It's going to check rule 1, rule 2, rule 3. So if rule 1 says allow, it will allow. If rule 1 says deny, it will deny everything that is going to come in. If rule 1 says allow, and then rule 2 says deny, and then rule 3 says allow, it's going to allow that one that is in rule 1. It's going to deny everything that will follow because the rule 2 says what? Deny. So it's not going to bother to check rule 3. So it's actually following the numerical order of the rule. It's following the numerical order of the rule. 10, 20, 30, 40, 50. Your rule number can come in tens or in hundreds. When you are naming, you can have 100, 101, 102, 103, or you can have 10, 20, 30s, anyhow you want to number them. Just make sure that as you're numbering those rules, you are thinking in your head possible scenarios. So you're not blocking what you wanted to allow by mistake. Okay. All right. So what are the other use cases for for NACL, right? Unlike security group that you can only set allow, right? You cannot set deny. It does not allow you to kind of puts a granular control, right, on access to the EC2 instance. But for the subnet level, the NACL, because you can set deny. So which means that if I have a rule now, right, that says allow HTTPS traffic, inbound rule that says allow HTTPS traffic from anywhere. Maybe I have now seen that all this anywhere, there are some particular IP address that I have seen over time that I've been trying to hack my application that is sitting inside my S2 instance on this particular subnet, right? I've seen some people that have been coming before and they look like arm robbers. Sure you get. I can decide that okay, the rule is going to be allow everybody from anywhere they are coming. But you see, Shegun, Tunde, and Kayode deny them. So I can specify the ones I don't want to allow. I can, so even though I'm saying allow HTTPS rule, right, from anywhere, I can now say that HTTPS traffic, if it is coming from this particular address, right, block it. Let's say for example, you have hotspots, right? You've opened your hotspot to everybody, you did not put password, so anybody can connect. So that's like your rule, right? Allow anybody to connect. Now you have now noticed over time that there's this particular phone's IP address that anytime that person connects to your hotspot like this, your data will just go otilo in few minutes. So, but you don't want to block every other person, because if you put deny, it's going to deny every other person, right? You don't want to, and you don't want to start listing all the names of everybody to allow Bishi, allow Shegun, allow Kayode, allow. You don't want to be doing that. So what you can do is allow everybody, right? Allow everybody to connect to my hotspot. But you see, this particular phone's IP address, maybe it's for Shade, block Shade's own. So every other person will be able to connect, but Shade will not be able to connect. So that's one of the advantages of the NACL. You can make it as granular as possible. Then also is that, since we said that security group does what? Allow um once it allows an inbound rule, right, it will allow the response of that rule automatically. So let's say for example, Yemisi is this HTTPS, she's coming from anywhere. Now, security group that is governing this EC2 instance, remember the EC2 instance always sits within the subnet, and security group is attached to an EC2 instance. Now, the security group you have set is that allow HTTPS traffic, which is Yemisi now, allow anybody that is bearing Yemisi from wherever it is that she's coming from, allow her to enter into this EC2 instance. Now, because by default, once you allow something in its security group, the corresponding response is also allowed, which means that if this security allows Yemisi to enter, because your rule says allow Yemisi from anywhere to enter into the EC2 instance, when Yemisi wants to go, it will automatically allow Yemisi to do what? To go. Like Kini was saying, what if she steals something? Now that is where the NACL can work. So automatically Yemisi will be able to leave the room, right? You can set a rule for the NACL. Remember, NACL is attached to the subnet, it's like the building. So your rule is bouncer, anybody that come in can go out. That's the automatic rule, right? Once the person comes in, the person can also go out. So Yemisi has gone into the room, she has gone out, but she has kept something in her pocket that does not belong to her, right? So now she now gets to the security man at the building gate, the building of the hotel gate, and she wants to go out. But you have already set a rule that only allow people to go out. Oh, sorry, this is saying inbound. I think I was rushing to make this. Only allow people to do what? To come in. Don't allow anybody to go out. Your NACL, that's the building, that is the rule that is guiding the building, your subnet, right, is saying that allow people to come in. So remember, if Yewande is coming now, Yewande, which is our HTTPS traffic, she will first pass through the security guard at the building. The security guard will check, what rule do I have? Okay, the rule says allow anybody that is wearing Yewande from anywhere to enter. Okay, so it will allow Yewande from anywhere to enter. It will enter into the building. Now Yewande will catwalk and go to the EC2 instance, which is the room she's going to. The bodyguard at the room, which is your security group, will now check what is the rule. Okay, the rule says Yewande from anywhere should be able to come in. So it will allow Yewande from anywhere to do what? To come in. Right. Now, when Yewande wants to go, she gets to the door of the room, right? She meets the security at the room, that's the bouncer. Now the security is like, Madam Yewande, you are going. Yes, so I don't dey go. He allows Yewande to go. Why? Because he has seen Yewande coming before, and the rule has already said Yewande should come in. So he just believes that once Yewande is allowed to come in, Yewande should be allowed to go. So Yewande leaves the room, right? She has pocketed something that does not belong to her, and she's about to leave the building. But you are wise, you have already put a rule that allow Yewande from anywhere to enter but don't allow Yewande from anywhere to go out. At least maybe not without searching in this our example, right? So Yewande now gets to the security at the building gate, at the hotel building gate. Now she has left the room. She's now at the hotel building gate and she wants to go out. Security now say, sorry, ma'am, you cannot go out until we search you. And that's how they will now catch you one day that she has steal something that does not belong to her. So that is one of the reasons why NACL is what is good. You can use it to restrict access as much as possible, even if the security group allows it, because the institute instance is still going to be sitting within a building. You can always still control and restrict traffic in and out. Hope we understand that. I think we're almost done. You mentioned if you remember it, and 10 is now is okay. Okay. Honor Okay. I'm so sorry. Oh. Can we all hear me now? Can we hear me and see my screen now? Um, so sorry. Light is dealing with me. My router went off. Okay. Okay, we can hear me and we can see my screen. All right. So thank God we're almost at the end. Somebody's having to do antenna for network here beside me. All right. Okay. So we can all still see my screen and we can see the comparison between the network access control and security group. And also, please pardon me in case you are hearing background noises because I'm outside now. I'm outside. Okay, all right. Thank you very much, Anoa. Okay, so let's quickly just run through. I think this is the last slide. So comparing security groups and NACLs based on different attributes. All right, number one attribute protection level. Security group is an instance level um, firewall, right? So it is connected to your instance. So it's an innermost firewall, right? While your NACL is subnet level, which means is outside of the um, instance, right? Is the outermost firewall. So you get to the NACL before you get to the security group, basically. Just like you talk to the security at the gate first before you go and talk to the bouncer at the room, right? Because you have to even be able to enter the building before you can access the room. Then use able pattern, right? For security group, it is many to many. Like I said before, right? It's you can connect more than one security group to one EC2 instance, and you can connect one EC2 instance to more than one security group. While for NACL, you can only connect um one subnet to more than one you can only connect one subnet to more than one NACL, right? You cannot connect one NACL sorry, you cannot connect one subnet to multiple NACL, right? You cannot connect one subnet to multiple NACL, but you can use the same NACL for more than one subnet, right? So it's one to many. Flexibility, your security group can span availability zone. Why? Because it's attached to the instance, so it can be attached to an instance that is in this AZ, and you can also attach it to another instance that is in another AZ. While for NACLs, it is restricted to that availability zone. Why? Because it is a subnet level, and subnets are usually within an availability zone. All right. So rule types, security groups only allow. It's only allow that you can allow. You cannot allow and deny. But for NACL, you can allow and deny. Um, Security group is stateful, and we've explained that. While NACL is stateless, and also for security group is not concerned about rule number. All it does is it checks all of the rules that you have before it makes decision. It checks all of the rules. So if you have rule number one saying deny, and then you have another rule at the bottom that is saying allow, it will allow, right? So it checks all of the rules before it makes its decision. But for NACL, it's following numeric order. If rule number one says deny and rule number two says allow, it's going to deny because that's the first thing that is seen. All right. So bringing it all together, right? We have our VPC, right? The VPC, of course, Internet Gateway. Now, the NACL is attached to the subnet. You can see the subnet here, right? The NACL is attached to the subnet. So when somebody is coming from outside, you enter inside the VPC. To first come and meet the security guard called NACL. The NACL will check the rule it has. If it's allowing it to allow the person to enter, right? And then when that person enters, it's going to check the route table will check, right? Is the person supposed to go to this instance or this instance? To direct it. If the person is going to this instance, then the security group of this instance will check, is this person allowed or not? To check. If it's allowed, it allows. While the one that is going here will also check. The one that is going here will also check if that one that is coming is allowed. So basically that's how they all work together, right? So NACL is at the subnet level, security group is at the instance level. All right, so this slide for additional resources, so you can always come here and click on the links that are there to read up more on some of these things. I think I've been answering our questions as we've been going, and we have just 2 more minutes. We have just 2 more minutes. Uh, oh, I'm so sorry that my network disruptions caused a lot of rancor. Please forgive me and forgive those that did not give us light. Okay, so if there's no question, let's do our knowledge check. Let's do our knowledge check. Give me 1 minute. Yeah. Okay, so can we go ahead to do our knowledge check? Yes, no, yes, no. Okay, all right, so knowledge check. Okay, so question one. Which of the following best describes a security group? Please read these questions and options very well before you answer. Read it very, very, very well. Which following one or A, it acts as a firewall, controls traffic at the instance level, and it allows or denies both inbound or outbound traffic. Number C, it acts as a virtual firewall for controlling inbound and outbound traffic at instance level. D, it routes traffic between different subnets. I'm expecting to see some confused answer, but I'll be very, very happy if I see plenty correct answers. Okay, so was our answer CB? Yes, I was expecting this CB, CB. Okay, CB, CB. All right. Learn from me, right? One of the mistakes I make is I like to reach fast through it. And the thing that I've realized AWS, especially in certain exams, the items in the line. Like, if you don't take them to read it, you know the question, then that's the answer, you'll be angry at yourself. So let's go like C. So it's C. And why is the answer not B? Why is the answer not B? Because this answer says that it allows or denies. Now, I already mentioned that security group only gives an allow. It does not give an explicit denial. So B cannot be. So C is answer. For those that just C, for those B, and then we know. So always be okay, so it's past 9 already, and we need so default behavior the newly created on any skill. About what the on any it allows all inbound and outbound traffic. It denies all and outbound traffic. It allows all inbound and outbound traffic, but it allows all inbound and outbound. It denies inbound, allows all outbound. Not the default one that comes with AWS, the one that is created by yourself. Oh shit, I've yes.